Let's look at applying our knowledge of the binomial theorem. So the first example says, find the coefficient of x to the power of 4 in the binomial expansion of 2 plus 3x all to the power of 10. So if we compare this bracket with the general form of a binomial expanded, then we have that a is equal to 2, and that b is equal to 3x, and that n is equal to 10. And so since we're trying to find the coefficient of x to the power of 4, we know that we would need b to be raised to the power of 4 to get a term that has x to the power of 4, since b is equal to 3x. So looking at the binomial theorem then, if we look at each of the terms one by one, we see that in the first term, b has a power of 0. In the second term, b has a power of 1. In the third term, b has a power of 2, and so on. So in the next term, b would have a power of 3, and in the term after that, b would have a power of 4. And that is the term that we would require to get a term that has x to the power of 4 within it. So looking at the first term again, when b is to the power of 0, we're choosing 0. We have n choose 0. When b is to the power of 1, we're choosing 1. When b is to the power of 2, we're choosing 2. So essentially, if we want b to be to the power of 4, we need to choose 4. So in this case, the term that has x to the power of 4 within it is the following. So we have n choose 4, so that b has a power of 4, and in our case n is equal to 10, so we would have 10 choose 4. Then we multiply this by a to the power of n minus 4. So if we look at this term here, n choose 2, we have a to the power of n minus 2. If we had n choose 3, we would have a to the power of n minus 3. So if we have n choose 4, then we would have a to the power of n minus 4. So in this case, we have a to the power of 10 minus 4, since our n is 10. So 10 minus 4 gives us 6. And then we're left with b to the power of 4 as well, since we're choosing the fourth term. So we have b to the power of 4. So in this question then, we have the following. So 10 choose 4, and our a is equal to 2. So we would have 2 to the power of 6, and our b is equal to 3x. So we would have 3x to the power of 4. If we were to work 10 choose 4 out, either using this formula or on a calculator, we would find that it equals to 210, and then 2 to the power of 6 is equal to 32, so we multiply by 32, and then 3x all to the power of 4 is the same as 3 to the power of 4 times x to the power of 4. So 3 to the power of 4 is 81, so we multiply by 81, and x to the power of 4 is just x to the power of 4, so we multiply by that as well. Now if we multiply 210 with 32 and 81, we end up with 1,088,640. And then we're also multiplying by x to the power of 4. And so the coefficient of x to the power of 4 in the binomial expansion of 2 plus 3x all to the power of 10 is just a number in front of x to the power of 4, which in this case is 1,088,640. So this would be our answer here. The next question says, find the coefficient of x to the power of 3 in the binomial expansion of 2 plus x multiplied with 3 minus 2x all to the power of 7. So first, we're going to look at the bracket that has a power of 7, and we're going to expand it out and write out a few terms. And then once we have done that, we will multiply the terms with this second bracket here, 2 plus x, and then whichever terms have x to the power of 3 within them, we will collect them together to find the coefficient. So 3 minus 2x all to the power of 7 can be written as the following using the binomial theorem. So a in our case is equal to 3, b in our case is equal to minus 2x, and n in our case is equal to 7. So using the binomial theorem then, we have 7 choose 0 multiplied with 3 to the power of 7 multiplied with minus 2x to the power of 0. And then the next term is 7 choose 1 multiplied with 3 to the power of 6 multiplied with minus 2x to the power of 1. The next term is 7 choose 2 multiplied with 3 to the power of 5 multiplied with minus 2x all to the power of 2. The next term is 7 choose 3 multiplied with 3 to the power of 4 multiplied with minus 2x to the power of 3, and the rest of the terms we're just going to indicate with an ellipse. So we only need to work out the term up until the power of 3 for minus 2x, because we're looking for the coefficient of the term that has x to the power of 3 within it. So if we were to work out the next term, we would end up with minus 2x all to the power of 4, and if we were to expand that out, that would leave us with x to the power of 4 within that term, which is what we're not interested in since we're trying to find the coefficient of x to the power of 3. So we only need to go up to the term that would give us x to the power of 3 within this expansion. Now if we simplify each of these terms, then 7 choose 0 multiplied with 3 to the power of 7 multiplied with minus 2x all to the power of 0 gives us 2187. Then 7 choose 1 multiplied with 3 to the power of 6 multiplied with minus 2x gives us minus 10,206x. Then for the next term, 7 choose 2 multiplied with 3 to the power of 5 multiplied with minus 2x all to the power of 2 gives us 20,412x squared. And then 7 choose 3 multiplied with 3 to the power of 4 multiplied with minus 2x all to the power of 3 gives us minus 22,680 x to the power of 3. And the rest of the terms we're going to write using an ellipse to indicate that there are other terms for this expansion left over. So now that we've written some of the terms for 3 minus 2x all to the power of 7, we know that we would expand this with the first bracket here, 2 plus x. So we're now going to rewrite this using just these terms and this first bracket here. So this question can be written as 2 plus x multiplied with these terms that we have here. So 2187 minus 10,206x plus 20,412x squared minus 22,680 x cubed, and the rest of the terms we'll write in using an ellipse. So if we were to expand these brackets out, we know that we would start with 2 and then we would multiply each of the terms within this second bracket with 2. Then we would look at x and we would multiply each of the terms within the second bracket with x. So within all of that multiplication, we are only interested in the terms that have x to the power of 3 within them. So 2 times 2187 wouldn't give us a term that has x to the power of 3 within it. Likewise, 2 times this second term wouldn't result in a term that has x to the power of 3 within it. So doing this multiplication, the term that would give us x to the power of 3 would involve the calculation of 2 multiplied with minus 22,680 x cubed, since that would then result in a term that has x cubed within it. So if we underline the 2, we know that the 2 is going to be multiplied with this term here, minus 22,680x cubed, to give us a term that has x cubed within it. Likewise, if we were to expand these two brackets out and now start multiplying with x times 2187 would give us 2187x, which doesn't involve x to the power of 3. Likewise, x times this second term wouldn't give us a term that has x to the power of 3. However, x times this term, 20,412x squared, would end up giving us a term that has x cubed within it. So the other calculation that we're interested in for this question is x multiplied with 20,412x squared. So the x cubed term involves the following calculation. So 2 multiplied with minus 22,680x cubed, and then we also have x multiplied with this term here, so we would add that on. So x multiplied with 20,412x squared. If we work this first term out, then 2 times minus 22,680x cubed is equal to minus 45,360x cubed, and then we're also adding on this second term, so x times 20,412x squared, which is 20,412x cubed. If we now add these two terms together, we finally end up with minus 24,948 x to the power of 3. And so the coefficient of x cubed in the binomial expansion of 2 plus x multiplied with 3 minus 2x all to the power of 7 is minus 24,948.